Alright, I want to look at a couple more examples, just kind of repeating that same thing. If, let me write it this way this time. 3 raised to the x power is equal to 14. And so we want to solve for x in this problem. Solve for x. So we're going to take the natural log of both sides. I'm sorry, the log. Okay, it doesn't matter. You can take the natural log of both sides. It doesn't matter. I haven't talked much about natural log, actually. I probably should have. But I did make the distinction that log, if it has a base of 10, we don't write anything there. If log has a base of e, okay, let's say for example has a base of e. Now base of e is 2.71 and goes on like that. That's what e is equal to. We don't put e here. I mean, we don't use log, we use ln. Okay, that's called the natural log, and we would just say, like, for example, the natural log of x. Alright, and nothing's written here because there's assumed to be an e here. That's the only difference between log and natural log. Natural log has a base e. Right? One more time. If it's blank, that means there's a 10 here. Right? We don't write log with base e. We write just natural log of x. Alright, good enough. Okay, let's move on. But I am going to say this, that we can use log or natural log. It doesn't matter. Alright, I'm going to go ahead and just use natural log just to show you. Okay, so you would just simply take the natural log of both sides and take that x out front, rewrite natural log of 3 is equal to the natural log of 14, and then you're solving for x, so we have x is equal to the natural log of 14 over the natural log of 3. Now, we could have used log up here, okay? In other words, I know this is crazy, but it turns out that the natural log, or the log 14 over log 3 is actually equal to the natural log of 14 over the natural log of 3. Plug in your calculator and test it yourself. Prove it algebraically. Okay, try proving that algebraically. Okay, so I don't know, I plugged in the calculator and it came out to be, I'm just going to write it up here. I know it looks kind of sloppy there. It's like 2.40 something, and I should write it approximately. So we do two little squiggly lines, meaning approximation. These are like if you were looking on your keyboard up next to the 1 to the left, you'll see a little squiggly line. Okay, it's called the tilde. They call that the tilde. It's like two little tildes is what it looks like. I'm not very good at drawing them out, but anyway, they're waves, like sine waves. Okay, whatever. Anyway, so that's just an approximation, remember, but this is the exact value, actually. Sometimes we can actually rewrite this, kind of simplify this stuff down, but we just leave it like it is. I don't think this stuff here can be simplified down any. But okay, so we know how to do these solving these simple exponential equations. Let's work something a little bit more difficult. And I can always come up with lots of more difficult problems, let me tell you. Alright, let's say we have 2 raised to the 5x minus 2, and that's going to be equal to 5 raised to the x power. So what we're going to do here is I'm going to go ahead and take the natural log, or the log, it doesn't matter. I'll just take the log. How's that? The log of 2 to the 5x minus 2, take the log of both sides, and we have 5 raised to the x. Now do the power rule thing on this. So bring the 5x minus 2 out, and you're left with log 2 is equal to, bringing that x out, and you have log 5. Okay, so we got to get this x isolated to one side of the equal sign. That's going to be the whole idea here.